Good day, grade 9s. I'm Miss Babo, and today's lesson we are going to be looking at chemical reactions and balancing. For this section, we are going to look at what different chemical reactions are and how to make a chemical reaction, as well as how to balance chemical equations. So let's start with a chemical equation. During chemical reactions, substances are changed into new substances. These substances will have new chemical properties and physical properties. During a chemical change, the bonds break between the elements and they will rearrange. This leads to new bonds that form a new product. If reactants go through a physical change, there will only be a change in phase or state, meaning it will become a solid to a liquid or liquid to a gas or vice versa. It does not always mean that a new compound is formed. We have several types of chemical equations which we can write, but first you must know the difference between the reactants and the products. When we start, it is the reactants. So these are the substances that we start with before a product is formed. The new substances that form are called the products or the product. So important to remember, the reactants will react with one another to form the product or the products. The first type of chemical equation which we are going to do is word equations. Word equations are the written equation of the chemical reaction that takes place. So if we use water as our example, hydrogen plus oxygen will react with one another to give us water, which is the product. During a chemical reaction, we can also write it as a chemical equation, which we use the symbols of the elements to react with one another to give us the symbols of the product. So our reactants here are H2 plus O2, and the product is H2O written in a chemical equation. Our last way of writing out a chemical equation is by using diagrams. So in this reaction again, if we use water, we have H2 plus O2 gives us H2O. The reactants of hydrogen, it is two white circles, and the reactant of representing oxygen is two red circles. This gives us the product of H2O. So the two white circles represent that there are two hydrogen atoms present and one oxygen. What's important to remember here is this is not a balanced equation. This is just showing you how to use a diagram to write out a chemical reaction. Now we can start with balancing chemical equations. In a balanced chemical equation or in balancing chemical equations, the total number and the type of atoms of the reactants must be the same as in the product. This is because that no atoms are lost or gained in a chemical reaction. They are just rearranged due to bonds breaking and bonds forming. When we do balancing equations, there are two important things that you need to remember. Firstly, the subscript number represented in a chemical reaction represents the number of atoms of that element that is found either in the compound or in the molecule. The coefficient number, which is the number found in front of the compound or the molecule, represents the number of molecules or atoms that react with another molecule or atom. If there is no number in front of a reactant or product, it means that there is one atom present of that molecule or of that atom specifically. If you look at the example provided on the right-hand side, the coefficients are represented in front of the elements and of the reactant. But the subscript are the small numbers placed in red. So if we have a look at the coefficients in this example, we have two hydrogen molecules here, and we have two water molecules that are represented in our product side. So this example here of 2H2 means that there are two hydrogen molecules present and each molecule contains two atoms. In this example, with regards to water, there are 2 water molecules present, or 2 water compounds present, each containing 2 hydrogens and 1 oxygen. Now we can start with the steps to show you how to balance an equation. So, step 1 is to identify the diatomic molecules on the reactant side. Remember, our diatomic molecules are H, O, N, Cl, Br, I, and F. That represents hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Step 2 is to write down the valency numbers of the products. Step 3 is to draw a line between the reactants and the products. This will indicate the difference between where the reactants are and where the products are, so we ensure that we draw the line underneath the arrow. Step 4 is to write the elements underneath the arrow, underneath the equation, with the elements of the reactants underneath the reactant side and the elements of the compound of the product under the product side. Then step 5 is to balance each element only by the multiplication of the coefficients. When we balance, we cannot just place any number between the elements as it influences the ratio. All the balancing coefficients must be written in front of the elements or compound, which will then even out the atoms on either side. And an extra hint is to start from the bottom. Remember, for this section, our valency number will be found on the periodic table. So let's have a look at an example of balancing equations. This example, we are using sodium chloride. We are going to be using the chemical formula of sodium chloride, which is Na plus Cl2, which gives us NaCl. So, step 1 is to identify what the diatomic molecule is. The diatomic molecule on the reactant side is chlorine, which is Cl2. Step 2 is to identify the valency numbers on the product side. The valency of sodium is +1 and the valency of chlorine is -1. As you can see here, we have already done step 1, and step 2 is not influenced on the product side as both are +1 and -1. Step 3 is to then draw a line, which is this one over here, that separates the reactants from the products. Step 4 is to write down the elements underneath the reactant side and the product side and how many atoms are found on each side. Step 5, we can now start balancing. Remember, when we balance, we only multiply the coefficient and not the subscript. So, if we start at the bottom, on our reactant side, we have 2 chlorine atoms. So on our product side, we need to multiply the chlorine by 2. Now remember, it's the coefficient that changes. So we add a 2 in front of our product, which then changes the number of sodium atoms. Now we have chlorine, 2 atoms of chlorine on either side, which is balanced, but 2 atoms of sodium on our product side, which means we need to multiply the 1 atom of sodium on our reactant side by 2. This gives us the final balanced equation of 2Na plus Cl2 gives us 2NaCl. To explain this example using the different steps set out here, step 1 will to be identify the diatomic molecule. Step 2 is to write the valencies of the products. Step 3 is to draw a line between our reactants and products. And step 4 is to write out our elements on the reactant side and our elements on the product side. The number of sodium atoms that we have on our product side and on our reactant side is 1. But the number of chlorine atoms that we have on our reactant side over here is 2. and on our product side is only 1. So again, we start with balancing. We start from the bottom and we work up. So chlorine is 2 on our reactant side, but only 1 on our product side. So we times that 1 by 2. That changes the final product to 2NaCl. And that means we need to times our sodium by 2 as well on our product side, which is now even. We have 2NaCl, so 2 sodium molecules, 2 chlorine molecules. On our product, on our reactant side, we now need to times sodium by 2. So on our reactant side, we have 2 sodium molecules that react with 2 chlorine molecules, and we have the product of 2 sodium and 2 chlorine molecules. If we have another look at an example of balancing equations, it is water. So on this side, we have our formula, which is H2 plus O2 gives us H2O. Now, this is not a balanced equation. So step 1 is to identify the diatomic molecules on the reactant side, and both H and O are diatomic molecules. Step 2 is to write the valency number of H and O2, which shows us which we do on the product side. Step 3 is to draw a line, which is this one over here, that separates the reactants and products. And step 4 is to write down the elements underneath our equation. Step 5, we balance only by multiplying, and again, we only multiply the coefficient, not the subscript. So if we start from the bottom, on our reactant side, we have 2 hydrogen atoms, 2 oxygen atoms, and on our product side, we only have 1. So first step is to multiply by 2 to ensure that our oxygen is the same on either side. Now remember, the coefficient gets multiplied, so our invisible 1 in front of H2O becomes 2. Now this means that the 2 in front makes we times the subscript by 2 there, because now we have 2 water molecules, not just 2 hydrogen atoms. So here becomes 4 hydrogen. So we times our reactant side by 2, as there are already 2 hydrogen atoms there. So our final balanced product is 2H2 plus O2 gives us 2H2O. If we have a look at our diagram equation over here, this is a balanced equation. We have 2 hydrogen molecules plus 1 oxygen molecule gives us 2 water molecules. To explain this example again, we start with step 1. So step 1 is to identify what our diatomic molecules are. In this reaction, both hydrogen and oxygen are diatomic molecules. Step 2 is to write our valencies above the product. Step 3 is to draw our line. And step 4, we cross over the valencies of our product. We now can identify how many atoms are present of hydrogen on our reactant side and on our product side, and we can identify how many atoms are present of oxygen on our reactant side and oxygen on our product side. Now we are able to multiply to balance the equation. So if we start at the bottom, oxygen on our product side has 2 atoms, but oxygen on our reactant side only has 1 atom. So we times 1 by 2, and again, we influence the coefficient and not the subscript. This then makes the number of hydrogen atoms on our product side 4, because there are now 2 water molecules, and in every water molecule there are 2 hydrogen atoms. So that means we have 4 hydrogen atoms on our product side, so we change it to 2 hydrogen, we times it by 2 on our reactant side, which gives us a product of 2H2 plus O2 gives us 2H2O. The last set of chemical equations which you must be able to balance in grade 9 is iron and oxygen, which react to give us iron oxide, magnesium and oxygen, which react to give us magnesium oxide, and copper and oxygen, which react to give us copper oxide. So if we have a look at these equations over here, we have 4 iron atoms that react with 3 oxygen molecules to give us 2 Fe2O3. The word equation is iron plus oxygen gives us iron oxide, which is rust, and it's displayed in this image on the right-hand side. For magnesium, we have 2 magnesium atoms that bond with an oxygen molecule to give us 2 MgO. Magnesium and oxygen will be the word equation that react with one another to form magnesium oxide. This is a form of a white powder, which we discuss in the next chapter. Our last equation is copper and oxygen. So 2 copper atoms react with 1 oxygen molecule to give us 2 CuO. The word equation is copper plus oxygen gives us copper oxide, and this is in the form of a black powder. Thank you for the lesson, grade 9s. We will see you next time with the reactions of metals and oxygen.